Welcome to the project demonstration of solar power grid status monitoring system along with alerting through Bluetooth. And the main application of this project is we are going to continuously measure the solar grid, nothing but the voltage, and the parameters will be continuously displayed on the 16:2 LCD screen, and the same details will be sent to the mobile phone through this HC05 Bluetooth module. And we are going to charge a battery pack of this solar, like from the solar panel, through this charging circuit. So whenever the battery voltage is low, it will indicate it through the buzzer as well as on this LCD screen, and same details will be sent to the mobile phone. And if the temperature near the surrounding system increases to 40 degrees centigrade, means whenever the temperature is above 40 degrees centigrade, then the system will provide us the audible alert through the buzzer as indication of high temperature. And to measure the voltages from these two sources, one is the solar panel to the microcontroller as well as from this battery pack. So we are using two voltage sensors, that is a 10:1 potential divider voltage ratio, and means whenever the input voltage is 12 volts from this battery pack or from the solar panel, so it will divide that to 10:1, means the output from the solar panel is 1.2 volts, as the microcontroller can't measure the voltage above 5 volts. So to measure this 12 volts battery pack, we are making use of potential divider to reduce the voltage to sufficient to make the microcontroller to measure that. Same for this voltage sensor from the solar panel also. So this the solar panel input voltage is given as input to the voltage sensor as well as to this charging circuit, and the battery output is input to the microcontroller to measure continuously voltages as well as to this voltage sensor, and the temperature sensor was connected to the microcontroller motherboard. So these are the main features. And coming to the components, we are using solar panel 12 volt 3 watt solar panel. The output from this one input to the voltage sensor and charging circuits. And coming to this charging circuits, we can see the 4 diodes. Generally we are using the 4 diodes as a rectifier purpose. So when we are providing the AC inputs, then these 4 diodes will act as a rectifier, means fully rectifier, to convert the AC to pulsating DC. So whenever the sunlight is not available to charge this battery pack, we have provided this transformer, which is not the part of the project, but to charge a battery pack we provided this. Just on the power supply to this transformer, then the light will be indicated as the battery is charging. So it will take around 4 to 5 hours to be fully charged. Till the duration we should keep the battery under charging. And when we provide the AC input, these 4 diodes will acting as a rectifier to convert the AC to pulsating DC. But when we connect this solar panel over here, these 4 diodes will acting as a polarity correctors, means as we are using the DC power source which has a polarity based. So if we connect that to charging purpose, then we should connect the plus to plus, minus to minus. So if we connect reverse bias, then the battery or the solar panel may get damaged. In order to protect the polarity correction, then we are going to use the 4 diodes which will acting as a polarity corrector when we provide the DC input to that. When we provide the AC inputs, the 4 diodes will acting as a bridge rectifier to convert the AC to pulsating DC, and the filter just to remove the ripples while we are providing the input to that. And these 2 diodes will acting as a unidirectional current flow purpose. Whenever the battery is fully charged, these diodes will block the current flow from the battery to the source, so in order to protect the reverse current protection. So this is about this charging circuit. So once the battery is fully charged, either from the solar panel or from the transformer, so 4 to 5 hours working hours minimum required to charge a battery pack. And coming to the battery pack, we are using 12 volt 1 amp rechargeable battery pack. In this 3 4 volt 1 amp batteries are in series, so we'll get 12 volt 1 amp DC output. That is the input to this our main motherboard. And when we switch on this regulator will regulate this is a regulator, so which will regulate the 12 volts DC to 5 volts of DC, as the 5 volts DC is the operating voltage of our whole system. So when we get the 5 volts, the system start reading input from the voltage sensors, and same data will be displayed on the 16:2 LCD screen. And if is any abnormal detected, the buzzer will be on, and the Bluetooth module will send the data to the mobile phone. So let us see demonstration. So before demonstration, first of all we need to install one application, that is serial Bluetooth terminal from the Play Store. After installation, go to Bluetooth settings. Now we can on the kit. A welcome message displayed on the LCD screen, and pair a new device. So when we are demonstrating the kit first time, then we should have the Bluetooth SS05 in our pair devices. If it is not there, pair from the new pair device and wait for HC05, right? So the password is 1234. After pairing from the settings, next time onwards directly we can go to the application part, options, devices, right? Then we get the HC05 over here. So once we pairing from here, so the device will be connected continuously, sending the solar voltage, battery voltage and temperature, same which is available on the LCD screen. It is continuously uploading the data to the our mobile phone application through the Bluetooth. So let us, if we increase the temperature, so whenever the temperature crosses the 40 degrees centigrade, then the system will provide us the audible alerts and also message alerts on this mobile phone. So if we place more lighting on this solar panel, flash it on. Right. So we can see the light intensity is increased from the charging circuits, and also the voltage also will increased. Right. So the solar panel voltage is 2.1 volts, and whenever it is no sunlight on the solar panel, we can see the nearby 0 volts. So in this manner, the solar grid station continuously monitoring through the Bluetooth along with temperature and alerting system.